Machephy Eduworld.
Students who have joined late, so we are solving problems again. So there is a magnetic field, uniform magnetic field, and it is directed into the plane of the paper. And I have a charged particle of mass m and charge q, which is moving with speed v. Now at t is equal to 0, I just switched on this magnetic field. So you have to find the force and the direction of the force. Then you have to derive the formula for radius of this trajectory. It will be a circle, of course. Then you have to find the time period, then find the momentum and the frequency of the charged particle. Okay, here should tell me the direction of force first and the value of the magnitude. Hirshit, can you hear me? I think Hirshit's mic is not working. Nupur, can you tell me the value of force? F.
Sir, QV into QB naught.
QV into B naught. Yeah. And the direction of the force? Will it be up, down, right, left, top, bottom?
Sir, up.
Yeah. Direction is upwards. So force is perpendicular to velocity. So motion will be a circular motion. I'll draw a good circle. Like this. So particle will move like this. Nupur, tell me the value of radius.
Sir, MV into sin theta by QV.
mv into sine theta. Theta is 90 degree because angle between velocity and this magnetic field is 90 degree. So sine theta is 1. So mv by q.
Yes.
Apurav, tell me the value of time period. Time taken for one revolution.
2 pi r by v.
हाँ, तो r by v को mv by q भी लिख सकते हैं यहाँ से.
Yes, sir.
So that will be 2 pi m by qp. अच्छा, एग्जाम में 2 pi r by v लिखने पे मार्क्स नहीं मिलेंगे. That is from circular motion. Okay, tell me the momentum. mv. Now for the momentum, we can write just qb into the radius.
Sir, r qb.
R qb, correct. And then the frequency. Frequency होता है 1 upon time period.
qb by 2 pi m.
qb by 2 pi m, correct. Okay. Abhi, we have this exactly the same thing, same system. And with a little modification. In question 2, you have the magnetic field in the downward direction, same thing. And the charged particle has velocity v. Mass of charged particle is m, but charge on the particle is minus q. Charge on the particle is minus q. It is negatively charged. And now you have to find out the same things. The charge is negative. So what will happen now? That you have to figure out. What things will change, what things will not change. So first tell me the value of the force and direction of the force. Mehul, what will be the value of force?
Sir, magnitude of force will remain the same.
Yeah, it will be QV B naught. And the direction of the force?
Will it be downward?
Yeah, it will be downwards. So we'll use this instead of Q, there is minus Q. So we'll solve for V cross B, but the direction of the force will be opposite to V cross B. So force will be in the downward direction. So the circular motion will be like this. So force will be in the downward direction. That's it, and the rest of the things will remain the same. For radius, everything, the magnitude of everything is not affected by the sign. So all of these things will remain the same. Only the direction of motion changed due to the direction of force changing. Here it was anti-clockwise motion, here it is clockwise motion. That's the only change. Okay, next question. Suppose I have the magnetic field limited to a region. I have magnetic field into the plane in this half region. Cross means the magnetic field is into the plane. So this is magnetic field B naught. And what I'm going to do, I'm going to project a positively charged particle inside this magnetic field region. Charge is Q, mass is M. Charge is Q, mass is M. So you have to analyze the motion. You have to analyze the motion and tell me whether the motion is circular or any other type of motion. And you have to find, first is analyze motion. Then in analyzing motion, you have to draw the trajectory. Draw the trajectory of the particle. Then you have to find time for which Q, charged particle Q, stays in the magnetic field. Stays in the magnetic field region. Then you have to find change in momentum. You have to find change in momentum of charged particle Q. Solve this. Think about how the motion will happen.
Sir, could you repeat your question? Means how it is separated?
So earlier the magnetic field was in the full region, but this time the magnetic field is only this half region. Means in this line only, in this part of only. There is no magnetic field in this region. No magnetic field in this region. And in this region, there is a magnetic field B. So the charged particle is projected towards it. So it will enter this region. There is no boundary, but there is just a dotted line. Dotted line के इधर magnetic field है, dotted line के इधर magnetic field नहीं है. So how will the charged particle behave? What will be the trajectory that you have to figure out? Anyone got the answer? From here to here, the charged particle will move straight, but just as it enters the magnetic field region, there will be a force on it in this direction, of course. So this force will cause the charged particle to turn. So it will try to go in a circular motion. Of course, it will go in a circular motion, but it can't make a full circle. So it will just be ejected from here. It will only make a half circle. Charged particle will make only a half circle. So this will be a trajectory. It will be a semicircle. Now you have to find the time for which the charged particle stays in the magnetic field. So for full time, that will be 2 pi m by qb. For half time, that will be half of the time period. So 2 pi m by qb. So this will become pi m by qb. That will be the time for which the charged particle stays in the magnetic field region. And if you want the change in momentum, that will be final momentum minus initial momentum. So final momentum is P final, that would be mv, and initial momentum is in the opposite direction, so minus mv. So change in momentum will be twice of mv. Or if you want to write the direction, then if you want to take this forward as x, then this will be minus mv minus plus mv I cap. So minus 2 mv I cap. That will be the change in momentum. Okay, next question. Suppose there is a magnetic field B along the x-axis, and there is the velocity of the charged particle is making an angle 60 degree with the magnetic field. In this case, you have to draw the trajectory. First is draw trajectory. Then write the time period. First do these two things. So velocity is at an angle with the magnetic field. So to take component of the velocity along the magnetic field and perpendicular to the magnetic field. Once you're solved, just put a message in chat. And of course, the trajectory will be a helix. So after finding the time period for one revolution, you can also find the pitch of the helix. In this case, first we'll do is take the component of velocity along the magnetic field. This will give me V naught cos 60, so V naught by 2. And another component that will be perpendicular to the magnetic field. So that will be V naught sine 60. That will be V naught root 3 by 2. So V naught root 3 by 2, this is responsible for the circular motion. And V naught by 2, this will be responsible for straight line motion. And combined together, they will form a helix. So trajectory will be a helix. And force will be like this. So the helix will be forming like this. So radius will depend upon this velocity which is perpendicular to the magnetic field. So I can write the radius as mv sine theta. Sine 60 is root 3 by 2. So root 3 by 2 by qb naught. Similarly, we can figure out the rest of the things. Time period will depend on the same thing, same velocity. It is 2 pi r by this velocity. So 2 pi m by qb naught. And if you want to find the pitch will be the horizontal velocity into this time period. Horizontal velocity is v naught by 2 and time period is t. So 2 pi m by qb naught into v naught by 2. That will be pi m v naught by qb naught. That will be the pitch of the helix. All right, any questions about this?
Sir, what will the force be in this case?
The force will be just qv cross b. That will be qvb sine theta. Theta here is 60. So it will be qvb, qv naught b naught, sine 60, that will be root 3 by 2. Anything else?
No, sir.
Okay. So when velocity makes some angle with the magnetic field, the motion of the particle will be a helix. Next question is like this. The direction of the magnetic field is into the plane everywhere. Value is B naught. And the charged particle is initially going in this direction. Charged particle has charge Q. Value of mass is M. And velocity is V naught. The question is, find electric field. Find the magnitude and direction of electric field. Find the magnitude and direction of electric field such that particle keeps moving in the straight line. Such that particle keeps on moving with V naught. Keeps on moving with V naught, or velocity does not change. Such that particle's velocity just does not change. Magnetic field is into the plane everywhere. Value is V naught. Anyone got the answer? So you can use this net force.
Downward. The direction is downwards and the magnitude is VB.
Yeah. So direction of electric field is downwards and magnitude is VB. That is correct. Because when you apply the magnetic force, the value of the force will be equal to QVB. Force will be equal to QVB and it is up in the upward direction. So to balance that, you will need an electric field in the downward direction. Okay. Repeat this question if the charged particle is negative. So negative charge particle, mass is the same. Magnetic field is into the plane everywhere. and charged particle is moving with velocity v naught. You have to find the direction of electric field and also its magnitude.
Direction will be upwards and magnitude will be same.
Yeah, magnitude will be same and direction. What will be the direction?
Upwards.
Upwards. Achha, what is the direction of the magnetic force? QV cross P. That will be coming in the downward direction. This is the magnetic force equal to Q V naught B naught. So this is a negative charge. I want the electric force in the upward direction. Electric force in the upward direction. So direction of electric field should be downward. Direction of electric field should be downward because force will be minus QE. So electric field should be perpendicular to velocity, but in the same direction as the direction of force. So electric field direction should be downward here also. Got it?
No, sir. Can you repeat?
See, force due to magnetic field is in the downward direction. So force due to electric field should be in the upward direction. नेगेटिव चार्ज पे जो फोर्स लगता है वो इलेक्ट्रिक फील्ड की डायरेक्शन के ऑपोजिट में लगता है. Electric field tells you the direction of the force on the positive charge. So here it is a negative charge. So electric force will be opposite to the electric field.
Yes, sir.
Okay. So here magnitude will be the same and direction will be the same as direction of electric field will be the same as the direction of the magnetic force. Okay, next question. So in the next question, I have an infinite wire. It contains a current of 3 ampere and this PQ is infinite. It is infinite. It has a current of 3 ampere and 1 meter away from this wire, I have an electron which is moving in the downward direction. And the speed of the electron is 2 into 10 raised to 7 meter per second. You have to find force on electron, find force on electron and its direction. Force on electron and its direction. Solve this, get me the magnitude of this. Of course, I will use mu naught as 4 pi into 10 raised to minus 7. First, you will find the magnetic field due to the straight wire. And that magnetic field will apply a force on the charged particle which is moving. And then you will calculate the value of force.
The angle between B and B is 90, right?
Yes, if you calculate the magnetic field, the direction will be into the plane for the magnetic field.
Magnitude is coming as 19.2 into 10 raised to minus 9 Newton.
Okay, first I'll calculate the magnetic field due to this. It will be mu naught I by 4 pi r. Mu naught is 4 pi into 10 raised to minus 7. Current is 3 ampere divided by 4 pi r. 4 pi r is 1 meter. So this magnetic field is 3 into 10 raised to minus 7 Tesla. That is SI unit. And force on this will be QVB. So EVB. Charge on electron is 1.6 into 10 raised to minus 19. Speed is 2 into 10 raised to 7. And magnetic field is 3 into 10 raised to minus 7. So 3 to 16, 9.6 into 10 raised to minus 19 Newton. That will be the amount of force. And magnetic field here is into the plane. Magnetic field is into the plane. That means if you apply V cross B, the force will come as in this direction. Sorry, but you have to reverse it. So force will come in this direction. So the value of force, direction of force will be in this direction.
It is infinite long wire, so it will be
2 pi r. I will multiply everything by 2. This will be 2 pi r. Ten raised to minus 18. Is this okay? That will be the value of force. Okay. Next question. So I have an arrangement like this. There are two circular arcs and they're joined together to make a current loop like this. Let us say this radius is 1 millimeter. And radius of the bigger circle is 2 millimeter. The current is in the clockwise direction. The value of the current is 100 ampere. You have to find if a charged particle here, just at this instant, it has a velocity of 10 raised to 7 meter per second. And the value of charge on this particle is 500 coulomb. Then find force on Q and its direction. And direction of force. Also, it is given that this angle is 120 degree. Try this. First, find magnetic field due to all these 4 wires. And then find the force on this charged particle.
Sir, we have to take distance from the center of Y, right?
नहीं, ये पहला वाला सर्कुलर पोर्शन है, दूसरा वाला भी सर्कुलर पोर्शन है। इन दोनों से तो
वो
मैग्नेटिक
straight
स्ट्रेट वाले से तो एंगल 0 और 180 बनेगा, तो उसकी वजह से कोई मैग्नेटिक फील्ड नहीं आएगा। sin 0 sin 180 हो जाएगा। स्ट्रेट वायर की वजह से कोई मैग्नेटिक फील्ड नहीं आएगा।
but angle तो ना हाँ 180.
First, I'll find the magnetic field due to this smaller loop. So for a full loop, the magnetic field is mu naught I by 2r. And if angle is limited, then it is theta by 2 pi. So here theta is 120 degree, 120 degree is 2 pi by 3. If I put theta in here, I'll get mu naught I by 6r. So this magnetic field will be out of the plane. So let me call this as r. So this one will become 2r, 3r, sorry. So magnetic field B1, that will be mu naught I by 6r. This is out of the plane, plus magnetic field due to the other one, that will be this, have the same value, mu naught I by 6r. But instead of r, we'll use 3r, because 1 millimeter plus 2 millimeter, the total will be 3 millimeter. And this will be out of the plane. Curl your fingers, it will come into the plane, not out of the plane, into the plane. So let me take out of the plane as positive, into the plane as negative. So mu naught I by 6r, 1 minus 1 by 3. This will be in the outward direction. Putting the values that, okay, let us put the values in the end. This will be 2 by 3, mu naught I by 3, 3 is 9 r. That will be the value of net magnetic field at this point. So force will be, magnetic field will be out of the plane. Force will be QVB. Q is 500 coulomb. Velocity is 10 raised to 7. And magnetic field is this. Here, mu naught is 4 pi into 10 raised to 7. Current is 100 ampere by 9. R is given as 1 millimeter, 10 raised to minus 3. 4 pi into 10 raised to minus 7. So this gets cancelled. So 4 pi, 5, 4, 20. 2 pi by 9 into 10 raised to 6 Newton. That's a very high value of force. Probably due to the reason that 500 coulomb is a very high amount of charge. So 2 pi, that is approximately 6 by 9, that will be approximately 0.7. That will be
What will be direction of force?
So this magnetic field is out of the plane, velocity is towards left. If you curl your fingers, your force will come in this direction. This will be the direction of force. Let us do one more question. So we have a straight wire. There is a small gap. And in that small gap, we are attaching another circular loop like this. The radius of this loop is, call it 10 centimeter. The current, let us take it as 8 ampere. Then you have to find the magnetic field at point O. Find magnitude and direction at point O. Magnitude and direction of magnetic field at point O. So this is a infinite wire, not semi-infinite, but you can consider it as two semi-infinite wires or a single infinite wire. It's just a small gap, so you can ignore that gap. So the net magnetic field here will be sum of the magnetic field into straight wire. That will be mu naught I by 2 pi r. And the direction for the magnetic field for both will be into the plane. So plus magnetic field due to a circular ring. That is mu naught I by 2r. If we calculate this, it will come out to be mu naught I by 2 pi r. Take this as common. And here it will be 1 plus pi. Putting in the values, mu naught is 4 pi into 10 raised to minus 7. Current is 8 ampere, 2 pi is 2 pi, radius is 10 centimeters, so 0.1 meter. 1 plus pi, that was 4.14. This goes 2 times. So 16 into 4, 64. Approximately 65. Into 10 raised to minus 6. That will be 6.5 into 10 raised to minus 5. Tesla, of course. So approximately this much value. So both the magnetic fields are added together. Both the magnetic fields are added together. Let us do another question. In this question, there is a loop here. And current in the loop is 10 ampere. Radius of the loop is 1 millimeter. And magnetic field is like this. Value of magnetic field is 10 raised to 5 Tesla. This magnetic field is external. This is external magnetic field. The question is, find torque on the loop. Find torque on the loop. Remember the formula for torque is m cross p, where m is the magnetic moment. M is written as number of turns into current into the area vector. So here the magnetic moment, that will be 1 turn, current is 10 ampere. and area will be pi r square. R is 10 raised to minus 3 because it's in millimeter. So this will come out to be 10 raised to pi into 10 raised to minus 5. Unit is current, ampere into meter square. So torque will be m cross p. So pi into, that is mb sine theta. The direction of the magnetic moment, it will be along the direction of the perpendicular to the area. So perpendicular to the area. So this has direction out of the plane. Magnetic moment has a direction out of the plane. So mb sine theta, that will be sine 90. This will be mb sine 90 degree. That will be just m into b. So m is pi into 10 raised to minus 5. And this is 10 raised to 5. So Newton meter will be the SI unit. So torque is just pi Newton meter. That is 3.14 Newton meter. That will be the value of torque.